Hi, and welcome to the Simple Container Automation with Podman and Ansible session at ansiblefest 2021. My name is kvegh, Charlie for short. I'm an infrastructure solution architect at Red Hat Austria, focusing more on RHEL and Ansible. And with my good friend and colleague, Robert Baumgartner, Bob for short, who focuses more on OpenShift and containers, we too have decided to deliver this container automation session to you. So this session is literally going to be about the question, can I automate container tasks on Linux with Ansible? And the answer is obviously yes, sure you can. You can automate everything with Ansible, right? Now, if you extend that question to, can I extend my container orchestration and automation with Ansible on top of Linux and Podman so that I can replace Kubernetes, then Bob, being the more OpenShift focused guy, he is going to say no. No, it doesn't work that way. Now, if you ask me, the more infrastructure and Linux and Ansible oriented guy, my answer is going to be also no, right? The only difference being is that I'm going to add, believe me, I tried, right? So what this session is not about is this is not how we can replicate all the features that OpenShift provides for container orchestration. You just can't. It's not possible. Now, what is this session really going to be about? This session is really going to be about the right container use cases that you can automate with Ansible, right? So we are going to look into what Podman is, if you are a container newbie, what it really does. Then we are going to look into what resources you have within Ansible to automate those processes with Podman. Then we are going to dive headfirst into the demo with 4 use cases that we have prepared for you guys. One being we are going to run 2 standalone containers. They are going to play the major role in our demo use cases. One container is going to be a database container running Postgres, and the other one is going to be a Node.js application container talking to the database in the other container. In our first use case, we are going to just run them, run them standalone. And that's it. They are going to be rootless containers, and we are going to show you their functionality, right? In the second use case, we are going to stick these containers into pods, separate management entities of containers, right? But they're still going to be rootless containers. This one leads us to our third use case where we can scale out with several pods containing different containers. But in the third use case, we are already going to move away from rootless containers, and we are going to have separate pods connected with a separate network. So we are going to create here a CNI network, a Podman network for them to communicate through, right? And last but not least, probably the most interesting use case is going to be replaying a kube YAML file, meaning Bob has taken one of his OpenShift installations and he has extracted a kube YAML file describing a pod environment there. He has provided me that YAML file. I'm going to replay it on my Linux Podman Ansible environment, right? To replay that environment. Now, to pep stuff up, we could all do this, old school on the command line with Ansible playbook, right? But I thought it would be more insightful, if you will, if we would use the Ansible automation platform 2.x setups as well. So from the second use case onwards, we are going to work with execution environments. We are going to stick that collection into an execution environment, and we are going to run that playbook against that execution environment with Ansible Navigator. We are not going to build our own execution environment. It's out of scope. Feel free to message me and I can show you how you can do that. Or I mean, there will be other sessions about this as well. But we are going to use Ansible Navigator against an execution environment running from the second and the third use case. And the fourth use case, we are going to step it up even more. We are going to execute it through the automation controller, what used to be Tower, right? So Podman. Podman is the right place to start with containerization if you are a Linux guy, right? Podman is a tool that is an OCI, an Open Container Initiative compliant container engine on top of Linux, and it does all the functionalities and way more that you can imagine that you need for container workloads, right? The first steps are always, log in to a container registry where you list all the container images available for you to use, pull some of those images so that you can use them locally, and then instantiate with Podman some containers running on top of those images. That's what we are going to do, right? Only we are going to use Ansible to automate it. Now, how do we start with a use case like this? So how do we approach a container automation use case? We approach it actually like any other use case. We get to know the technology first. We work with Podman, right? On the command line. We get to know it. Then we look into what Ansible resources do we already have available to use so that we don't have to reinvent the wheel. We'll see that there is actually a Podman collection in the Ansible community that we are going to use, right? And we have realized that. Let me actually show you that. So if you are starting, I'm always looking into the Ansible collection index. And if I look into that, I list all the collections that are available as of now. And what I do is I search for containers here, and I have realized that we have the containers.podman collection. It includes all these modules, which are very, very helpful. And if we look into it, we'll see that these are actually the ones that we are going to need, right? So there are Ansible modules here to log into a container registry, what I have mentioned. You have to authenticate against it, list the images you have, and you can pull images for you to use locally. Then with the Podman image module, you actually can pull those images. And if you have pulled images and they are available locally, then you can, with Podman containers module, you can start instantiating containers on top of those images, right? So there's an official containers.podman collection that we are going to use, which is great because where is my presentation? Here it is. Because of course we do not need to reinvent the wheel. So all I needed to do in this case was that of course I created a separate new Git repository. Any software repository will do. In my case, it's GitHub. I created a new repository and I started writing my roles, right? That I want to demonstrate to you, these 4 use cases that I have mentioned. When they have reached a certain maturity level, I have published the collection I have built, right? And this is very important. I want to emphasize this. Collections are the new level of hierarchy to share automation content with, right? So I have published it to Galaxy. In my case, I use Galaxy here. If you are working in an enterprise environment, then it's probably more the Red Hat automation content hub, or even better, the private content hub that you can run on premises in your data center. Anyway, that collection needs to be published somewhere for others to consume, right? And because we are running Ansible Automation Platform 2.x, we from the second use case onward, I'm going to run these use case demonstrations against execution environments, right? So not only am I going to manage containers on my remote nodes, I'm also going to run Ansible itself in a containerized execution environment to get that work done, right? So containerized execution environments are also the new way of sharing, literally execution environments. Last but not least, when I built that collection, stuck it into an execution environment, a container image, that container image I shared in a container registry for others to use. That's how my Ansible navigator is going to execute my playbook against, and that's what my automation controller, Xtower, is going to use to run my workload, right? But let's bring on the demo at last. Now, so this is my environment. This is just a lab environment. It's really nothing special. What I want to show you is that as far as I remember, I have no collections, no collections installed, right? So the list tells me nothing. So what I'm going to do is I need to install that collection. The kvegh.podman automation demo collection is one that I have published on Galaxy. Right, so here's my content. Here's the Podman auto demo collection. This is public stuff, but word of warning, this has been built for this demo purposes, so it isn't 100% best practices, right? But what it does is it's available. It delivers the collections with the roles I have built for Podman container automation, and it also depends on other collections whose content I'm going to use in the demo, right? So now that I have my collection installed, I have here somewhere a demo test environment, right? So we have our collections. Let's see where the roles are. Ansible collections, kvegh namespace, Podman auto demo roles, right? So what am I going to do here? I have here 6 roles altogether for 4 use cases. The 2 extra ones are cleaning up previous environments to have a clean environment always for the next tests, and the preparation role, right? So what we should look into is probably the prepare environment tasks, right? I have mentioned that there is an official Podman containers Ansible collection, right? And I have shown it you that my collection with my roles depend on that. So I have now installed all of them. So now I can use them practically. I'm using them with the whole namespace naming, right? The first step is logging into some container registries, right? For that, I'm going to use the Podman login module with my credentials. My password, I obviously had to put external into a vault. And this module is going to log in with my credentials into the registry.redhat.io container registry. That's where I'm going to pull the Postgres database image from, right? I'm going to use a second container registry as well, because Bob has built for me this Node.js application that is going to talk to the database, right, from a separate container, and he has pushed it to kvegh.io, right? So I'm logging into 2 container registries with the according Ansible modules, and when I have logged in, I'm going to pull the Postgres 12 image, the official rel 8 Postgres 12 image, and I'm going to pull Bob's Node.js application container image from kvegh.io as well. And that's about it, right? So this is preparing the environment. I'm just pulling the images. If I did that, then we can start actually with the first use case where we have already all those images pulled, and we can start instantiating containers, running containers on top of those. Okay. Now for that, I'm just using the podman container module from the very same collection, and I create a container named Quarkus test, another one called Node.js test, and I'm starting here the container on top of the database image, and I'm providing all the necessary parameters for it to run, right? Obviously, the database password I could have encrypted here as well. And here's the Node.js container application. Just the same module is used. It also gets a couple of environments variables, and it's going to talk through this port that we have mapped out to the database itself. It also will expose a port 8080, where we are going to be able to see the application interface actually. Right? So let's do this. Because we need to log in to the container registries, it is going to use my credentials. I'm going to have to provide this Ansible playbook extra variables so that it can authenticate against those container registries, right? I didn't put this neither into the collection nor into any playbook, right? So I'm going to provide this as external encrypted variables, right? But I'm going to start this as an old school Ansible playbook command, right? So if I'm running the use case 1 root class containers playbook, then I need to add the vault that contains my credentials. Right? And to decrypt that, I have to provide a vault password file as well. Right? So I'm just starting here an Ansible playbook, nothing new here really, right? This playbook calls first the cleanup role, then it calls the prepare environment role, and after that, this is the prepare environment where we log into the container registry and pulls the images. And when it did that, it instantiates the database container and then the Node.js container, right? So if we actually want to look into that, we can, let's see one of the hosts where we rolled out here. Now we have podman, right? Now podman shows us that we have on this end node that we manage, that we push the workload to, we have now 2 containers running, this one being the database container and this one being the Node.js container, right? And if you want to look, actually, if we, yeah, it's listening on the hosts, actually on the hosts provided network interface, we mapped that port. So actually if we connect there, I have here, actually, sorry, IP address show, so it's this IP, right? But I have it bookmarked anyway. So this is what the container actually provides. Now the application is running here. So it's a fruit stock management application writing into the database in the other container, right? So if we want to add here other fruits, we add here papaya, and I don't know. And then we have papaya, and there is a mamaya as well. This needs a lead number, right? So we can store data here, right? So 2 containers, nothing too fancy here. Right, so this is the first use case. We have here 2 containers running, not stuck in pods, and that's about it. Right, this is the first one. Now for the second one, I'm going to clean up the environment first. Now for the second use case, we are going to go still with rootless containers, but we are going to create the very same containers and we are going to stick them into pods, right? But to do that, I thought from now on we could actually execute against that execution environment Ansible automation platform 2.x style, right? And for that, I built an execution environment and I pushed it to kvegh.io, right? So what I'm going to need is, as not this browser, but let's say this one, kvegh.io. In kvegh.io, I have one repository and I can pull my podman automation execution environment, right? So do I have any images now? Right now I don't have any images here. So if I want to pull this thing here, I'm going to pull the execution environment that I have created. It contains all the collections and it's built on top of the official Ansible automation platform 2.x execution environment. I'm just adding my collections there, right? Now, if I want to run this second use case, creating a pod, let me show you that second use case. Use case 2, tasks main YAML. It is very similar to the first one, right? It creates containers using the same podman container module, right? But before that, I'm creating a separate pod, and I named it Fantastic Pod because I'm so full of fantasy. And I export there on the pod level, I export the port I'm going to use, right? And later on, when I create the containers themselves, I just name the pod that I want them to run in. And that's it. Now to run this playbook in the Ansible automation platform 2.x execution environments manner, I'm going to need a new tool, the Ansible Navigator. In this case, I'm going to need a new Python environment. I have here the use case 2, right? So if I want to run this playbook through an execution environment, what I need to do is I need Ansible Navigator that has been built to run automation workloads within execution environments, and I need to instruct it to run this playbook, and it needs a couple of extra variables as well. First and foremost, it needs an environment. Again, it needs authentication credentials, right? So needs extra vars. It needs a vault password file as well. Right? I need to instruct it to use with the use Ansible. I want it to run in standard out mode, and to write straight out to the standard out the output. We are going to look up in the interactive mode later on. And what else do I need? Obviously, I need to tell it to use the it needs to use the container execution environment that I have just pulled, right? And I need to give it an inventory too. Now, fingers crossed if I have all the parameters right? Let's see. It seems to run. This means Ansible Navigator itself. Oh, access denied. I know why. So what happens here now is Ansible Navigator actually looks at this execution environment that I have pulled in my images, right? It's here. And executes Ansible Runner and Ansible Playbook within that execution environment, right? And does it all with podman commands, right? That's an advanced use case to use podman for automation again. But now what happened is actually it started the execution environment. It started the has started Ansible within it. It has found the right playbook. It has found all the secrets necessary to decrypt the vault. It found all the hosts, but it says, unfortunately, I cannot log in. Ansible itself cannot log into that environment, right? Now, what happened here? Actually, Ansible ran, but over SSH, it couldn't authenticate itself against the end nodes, right? So how do I add into the execution environment at runtime the credentials so that Ansible can authenticate against those end nodes, right? I don't want to put there my password. I don't want to put this into my collection. I don't want to put my SSH key into the execution environment itself fix either. So here's a nice trick that I was shown. Is that what we need here is an SSH agent, and that's really a nice feature, that if I start an SSH agent and add my Ansible user's private key to the agent, then actually when Ansible Navigator starts up the execution environment, and within the execution environment it starts Ansible that connects to the end nodes and authenticates to get the container workloads set up, then it maps it loops that SSH private key into the running environment, right? So you don't need to manually fix it into fixwire it into the execution environment or into the collection. Ansible Navigator does this on the fly for you. Actually, it also bind mount the directory where you are running from, right? So if I start the same thing again, but now I have an SSH agent that manages my key, then this should be running now, right? So starts the container, and now it can log into the end nodes because it has the SSH key added to this running container on the fly at runtime. Kind of a nice feature. And the same thing with bind mount, right? So the directory where you execute Ansible Navigator from, that's going to be bind mounted into the executed container that is the execution environment, right? So you can bind mount data from the local directory into the running environment at runtime. That's nice. Now again, so what we did actually here is that we created containers in the fantastic pod. Let's have a look at that. Right, so if I'm now run podman ps, now see that I have here my database container running, my Node.js container running, and I have another container that is particularly an infrastructure container that is necessary to manage the pod's resources. Right, so Podman has done that automatically for me because I instructed it now to run this container in a pod. Let's see where they are running. All these containers are running in the famously named fantastic pod now, right? So that's the second use case, running containers in pods with Ansible, right? Now the third one we said is going to be what is the third one about? The third one, right, the scale out one, right? So the third one is not going to be anymore, it's not going to be rootless containers anymore, right? Because we are going to have separate pods, and we want these pods to be able to talk to each other through a separate network, right? So we are going to create a CNI network, a podman network, and all these pods are running separate containers, and they can talk to each other through the network, and actually through the host as well, right? Again, we are going to start the containers, and we are going to create a pod for them, and we are going to roll out a bunch of pods. But before we do that, we are going to create one podman network, a CNI network, actually. So that's it. And of course, when we create the pod, then we assign it IP addresses, and the containers are assigned to the pods. Here we go, to the right pods. They are all done here sequentially, right? So let's see that. But right now I'm not going to do this anymore in a standard out mode. I'm going to run this in an interactive mode, right? I think that's the default, but just to make sure that we get this. So what I started now actually is I have started Ansible Navigator, and it shows me that which plays are running, right? What the state of it is. If I still want to look at the standard out, I can, right? I can follow what's going on here, and it has pulled the images, and it has created here it created the pods, sequentially, and it also creates containers and sticks them into the according pod as well, right? So this is more of a scale out setup. The only difference being that it's not anymore rootless, but it's ruthless in meaning that we scale out by power. Now let's see. So this was a successful run. Fun part with Ansible Navigator is, which I really want to mention, that if you run in an interactive mode, then Ansible Navigator actually can capture the artifacts that have been generated through this run, and you can replay this run anytime in the future. So you can look into it, what happened with the run 2 days ago, right? So let's see. If I SSH now into that remote host, what I'm going to see is podman ps. I see that I will have a bunch of containers running. I need to reduce here the font size. What you see here is we have a lot of containers running, Node.js containers and Quarkus containers, right? And they have all port mappings, and we have also this infrastructure container that Podman has created without being instructed to do so, because we are running in separate pods. Let me show you that. Need to reduce this one more. So as you can see, we have here let's see. So we have here an infrastructure and a database and a Node.js container running all in the fantastic pod number 2, right? And the same environment we have in the fantastic pod 4, and so on and so on. So we have scaled out here. Now what we do have here is actually so what Podman did for us is has created a CNI Podman interface actually with that network, and all these pods are attached to this network and exposed their ports and can communicate through those addresses, right? So if I do let's say I have here somewhere exactly. So if I inspect with Podman, inspect the fantastic pod 4, and if I see what IP it has got the static IP 10.10.10.104. So if I curl that, I must have this somewhere. Right, I have 104 in the cache anyway. If I curl that port, and I will see that the Node.js application that we have looked at is there, right? Okay, give me a second. -e fruit.management, I think it's called. Fruit management, right? Not .management, right? So this is still the fruit management application we could look at, what we have looked at with the browser, right? So the only difference is that we have here a bunch of pods are all scaling out with the same application. So this, we can represent different customers, or if you have a scale out application, you can scale so as well, right? Right. Now the last use case. What is the last use case? Let us see. Oh, the last use case is the fun one. The last use case is actually where Bob, my favorite OpenShift guy, has provided me a kubeyaml file that he has extracted from his OpenShift environment and handed over to me. This is this pod 6+8 YAML file, and he extracted it from his OpenShift environment, and I'm going to replay it on my Podman environment, right? So Podman has this now replay feature, and this is what I'm going to steer with Ansible. I'm going to set up this network again after cleaning up the environment, and I'm also going to hand over this YAML file that Bob has extracted from the OpenShift environment, and I'm going to use the Podman play module to run this file that he has provided so that I can have the same environment like he did, right? Right, so, but I also promised you that I'm not going to do this through Ansible Navigator anymore, but we are going to use this through Ansible Automation Platform Automation Controller. That is, if I remember my user. Nice. So what we have here is the automation controller, you know, when the web interface and API, and actually, you know, automation job orchestration engine, something we used to call Tower back then. And now the automation controller is capable of running with execution environment. So this is the big architectural change. So that execution environment that I have built, and it's now on kvegh.io. This is the execution environment we used so far with Ansible Navigator. It contains all my collection and the Ansible collections that collection depends on as well. I have instructed the automation controller to pull that image, right, as an execution environment. So that has been already added here. And I created actually a template, a job template, which is nothing else than instructing, let's go through it. It's nothing else than instructing the automation controller to use my playbook repository, use it on this execution environment that it should pull from kvegh, and it should run my Ansible playbook file, right, that it got from Git. And yeah, it needs privilege escalation, right? So if I just start this very, very simple playbook, it's going to be a bit boring to watch because it's really very simple, but the outcome is fun, right? So it cleans up. We are going to ignore those errors because that's just lazy data handling on my end when cleaning up the environment. So what it does the cleanup, right? Then again, make sure that the container images are pulled because they are necessary. It creates a network. It makes sure that that a kubeyaml file is available, right? And when it's done, then actually goes ahead and executes that kubeyaml file. Let's look into that, what that really is. So I have shown you, this is the role. This is the kubeyaml file that Bob has extracted from OpenShift and provided to me. So I was lazy here and actually put this into the collection, right? So this is the kubeyaml file I got from him, and it describes this environment, right? It describes the environment variables. It describes the ports that he has all defined, right? Runs a couple of commands, specifies the containers, and so on and so on. So this is all that he provided, and this is what we are running now. So if I SSH again into that host, is it done yet? Replay kubeyaml file previously extracted. Nice. Did it run successfully? Let's see. Right, it did. Ran successfully. So we can look at the environment now. And that's it. It has created it has created 2 pods. Actually, right. It has created 2 pods, Fantastic Pod 8 and Fantastic Pod 6, right? So it created 2 pods, and it ran our heroes, those container images, the database and the application container image with them. But I didn't have to describe these one by one because Bob's cube YAML file had those described, and I just replayed it, right? So that's about it. That's actually, I think, the end of the demo. So let me go back to my slides, if I find them, that is. Right. So what have we learned today? First and foremost, the most important message here is, no, you can't. It takes a lot of effort to rebuild everything around Podman, all those services that OpenShift provides, right? Yes, you can create Podman networks. Yes, you can create Podman volumes. Yes, you can make sure that you manage your containers, but it's a lot of effort, right? So this environment is great to run a couple of dozens, maybe a couple of hundred containers managed by Ansible. But if you need serious production-ready environments, you are going to need monitoring, you are going to need scaling, you are going to need probably CI/CD, and so on and so on, right? So for simple use cases, Ansible for Podman automation is awesome, right? To get things running, to test out your architecture, right? But for production, go with OpenShift, right? But still, containers are Linux on Linux with Podman are very easy, right? And again, it's very important to store all your data in collections, right? And those collections can have dependencies, and only small implementations shall go into separate roles, right? Right. Podman automation is very simple because there is this Ansible collection available at your fingertips. The Podman container collection, right? Best practices include getting familiar with Ansible Automation Platform 2.x because you have already containers for the execution itself, right? And if you learn about Podman, then it's the right way to learn about execution environments as well. But you can learn about Ansible Navigator and Ansible Builder in separate sessions, right? But use those. Your life will be more modern and easier in the future through that. And again, it's so easy to build this environment because it's an open source environment. I'm not sure if you have recognized, but in the middle of the demo, I have switched Python virtual environments because I needed another version of Ansible Navigator. I was able to do that because Ansible Navigator is obviously open source like everything else at Red Hat. And I was able to upgrade to a version that hasn't been yet productized with 2 simple commands, right? So open source is also your friend here. With that, I would like to thank for your time in Bob's name and in my name, and also would like to thank everyone who was supporting this session. It was really a teamwork. Thank you very much, guys. You know who you are. See you around. Bye-bye.